One of the most difficult things to do with the kinematic equations is to take this one we have here and solve it for the variable t. In all the other variables, this equation is linear. However, in the term of t, it is a quadratic, which means it has a term to the power of t to the first, a term of power t to the second, as well as a term with t to the 0. In other words, a term that does not have t in it. We have to treat this equation like a quadratic when we solve it for the variable t. A generic format for the quadratic is ax squared plus bx plus c equals 0. In this case, a, b, and c are not acceleration or b and c being some physical concepts, and x is not always x. These are just mathematical symbols. In this equation, x is what the equation is quadratic in. In our equation, t is the quadratic variable. We need to solve our equation and make it look like the quadratic if we have any hopes of solving it for t. The first thing we need to do is get the t out here in front. The t squared out in front, that is. So I'm going to take and flip this equation. Everything on the right side I'm going to put on the left. Everything on the left side I'm going to put on the right. So I have vi times delta t. I have the positive 1/2 a t squared, and these are being added together. I simply just change the order, the commutative rule. And on the left side, which I move to the right, I have the delta x. Now, to solve this equation, I'm going to have to make it look like this. On the right side of the equation with the x squareds, it's equal to 0, so I will make this equation equal to 0 also. I will subtract the delta x from both sides. And this is what we need to do. Whenever we solve this equation, for x, we need to get everything off of one side onto the other. Whatever we do to one side, we have to do to the other. So what we're left with is 1/2 a t squared plus vi delta t, excuse me for not putting a delta over here, minus delta x equals 0. Alright, now let me take this. Let me see if I can get better capture of it. There we go. And I'm going to move this down here. Okay, now pay attention here. In this case, we have t squared, t, and no t. Down below we have x squared, x, and no x. On the right side of these equations, they both are solved for 0, so these equations are set up in the same manner. And here, on the top, the green one, we have a t, on the bottom we have an x. So let's consider the exponents out in front. The a in the equation on bottom, on top we have an 1/2 a, on the bottom we have a b. That syncs up with the vi. And here our negative x, negative delta x, is a c. These are the similarities between the two equations. We have an equation to solve for x in a quadratic. You may be familiar with it. Normally it's x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, this works when we're solving for x, where x has a the coefficient from the first term, b the coefficient from the second, and c the coefficient of the third. But we're not dealing with x in this case. We're dealing with t's. We will substitute in these equations down here our coefficients for the t's. for a, here and here, our coefficient is not a, it's 1/2 a. For b, down here and here, our coefficient is vi. And for c, right here, our coefficient is no longer c, it is negative delta x. So, since we're solving for t instead of x, I'll rewrite this. We now have delta t equals negative b, but our b is not b. Our b is vi plus or minus the square root of b squared. Our b, once again, is no longer b, it is vi. So we have vi squared. It's more of a y. Let's see if we can exaggerate a little bit to make it look more like a v. Scoot over a bit. Minus 4. What was our a? Our a is now a 1/2 a times 1/2 a, and our c. But now our c is a negative delta x times negative delta x. And all of this, of course, is still underneath the square roots. And this whole thing here, this whole thing right here, is divided by 2a. Divided by 2 and divided by a, where our a is 1/2 a. I know it's a little confusing, where in the bottom equation we have an a, and the top equation we also have an a. In this term, a is any coefficient. In the top equation, a is specifically the acceleration. So even though they're the same letters, they mean something slightly different. Alright, now, this is the unsimplified version of the equation to solve for delta t. We have started out with the kinematic equation. We've turned it into a quadratic equation. We assumed the equation we learned in algebra, substitute those values in, and this is the method we have to use to solve for delta t. This can be slightly simplified a bit more. We could simplify the 2 and the 1/2 on the bottom. We could simplify the 4 and the 1/2 here, but I will leave that to you. This is the equation to solve for delta t.